Hello everyone, my name is Kevin Tarr. I am an iOS engineer and today is day 18 of Algorithms in Swift. So today we're going to be focusing on counting characters in a string. We're going to write a function that detects how many times a specific character appears in a string. So there's several approaches to go towards this problem, but the trick about this problem is that we're not going to be able to use a for loop. So let's begin right now. So our problem states, without using a for loop, write a function that accepts a string and returns how many times a specific character appears. Take a case into account. So the letter B appears 3 times, and Betty Bopper bought a bit of butter. You see these funk tongue twisters down here. The letter W appears 6 times, and how much wood would a woodchuck chuck if a woodchuck could chuck wood? The letter P appears 7 times, and Peter Piper picked a peck of pickled peppers. If you remember nursery rhymes at elementary school and just famous tongue twisters, you remember that one. I remember it certainly. The letter T, capital T, appears once, and the thinker thought 2 times that thoughts could think too because there's only one capital T. Again, taking case into account. That clause right there, okay? Take case into account. So there are several approaches to this. I'm going to show you 2 really quick approaches that can solve this problem. And one is going to be in 1 line, one is going to be in 2 lines, okay? First, I'm going to show you the 1 line one. This is my preferable one, okay? So we could, let's call this counted characters. Character. Okay. We're going to return an integer. Okay. Basically, we can return. Basically, we can. So if you remember yesterday's problem, how we used the original string count and checked if it was equal to the filter string count. We checked if they were equal. If they were equal, we returned true. If they were not equal, we returned false. So we're going to do not exactly the same thing, but a similar concept. We're going to replace the occurrences of the character that's passed in, and then subtract from that count. We're going to subtract that count from the original string count, and that should give us how many times the character appears in the string. Okay, so we could do string.count minus string dot replacing occurrences of character with an empty string. Okay, dot count. Okay, and 1 line we should be able to solve that. So if we were to get this one, Betty Bopper bought a bit of butter, and pass in lowercase b. Three times, okay? And if we were to get Peter Piper picked a peck of pickled peppers. Oops, sorry, I put B. That's going to be 0. Let's see, P, lowercase p should return 7 times. Yep. Okay. So this works. And just one more time, we do with the thinker thought 2 times. I thought it's a good thing too. The capital T should return 1 time. Okay. Cool. Okay. So that's the first approach. Now we're going to do a second approach. Okay. I'm just going to create a function out here. We're going to call this counted characters 2. Do the same approach, and this time we're going to use functional programming to solve this. Okay. And we're going to introduce a new collection type that I haven't talked about in this series. Okay, so first, we're gonna um, hmm, we're gonna call this not counted array. We're gonna call this character array, and we're gonna map all the characters into a string. Okay, so this is going to be a string array. Okay, an array of strings. Okay, and then we're gonna yeah, so we're gonna introduce a new collection type, as I told you, which is an NSCountedSet. So NSCountedSet really quickly is a set. So it does the same things that a set does. It eliminates all characters and randomizes the set. However, it keeps a count of every character or every element, and all the times that it appears within a set. Okay, so we can knowing that information, we can use that to our advantage to ask the count for the element that's passed in to our function. Okay, so we use NSCountedSet. To pass in our character array, and then we can get a count for the character that's passed in. Okay, and that also should solve our problem. Let's get we didn't do. Let's do how much wood could a woodchuck chuck? Woodchuck could chuck wood. Okay, let's do that. Let's do W, lowercase w. We should get 6 back. Yep, it works very fast. Again, sets are O and constant, so O log constant. So they run on constant time. So no matter how many elements you have, um, it doesn't affect the time that it runs. It's extraordinarily fast. Okay. Betty Bopper bought a bit of butter 0 times. Okay. Now, oh, sorry, W. Now that we are mapping, so but us doing mapping once is not too computationally expensive, and we're not mapping a huge string. So, but that runs order n since we're going through every single element. That oh, sorry, I keep forgetting to. I'm so busy trying to explain logic, I'm forgetting to do the problem correctly. Okay, so lowercase p should return 7 times, right? And a thinker thought 2 times that thoughts could think too. Let's put that in here too. Let's put capital T. And just for fun, we put lowercase t 7 times it appears. I didn't run any tests to see how many times lowercase t appears, but let's see if these two match. Cool, 11 times. Beautiful. Guys, thanks again for watching. Hope you have a good night. Adios. Goodbye.